Here's our last video about percents, and this is about finding percent of change. So again, this is dealing directly with our learning goal, which is I can solve real-world problems involving percents, including simple interest, tax, tips, discount, commission, markup, and percent of increase or decrease. So here, when we think about percent of change, our proportion is pretty much the same, but we might want to think about the numbers a little bit differently. We're going to put the amount of the change, which you will most likely have to find, over the original amount. Original means first in time. So you have to think about which amount came first. And that will be our original amount. And then we still have percent over 100 because percent means out of 100. So here's a percent of change problem. Mid-Prairie Middle School had 303 students last year and has 310 students this year. What is the percent of change? And then there's a question, is it an increase or a decrease? I can answer the increase or decrease question right off the bat. If we went from 303 students to 310 students, that is an increase. It went up. Increase went up. Okay, now we need to figure out what we're going to put into our proportion so we can find the percent of the change. We need to find the amount of the change. Well, we went from 303 students to 310 students. That means we went up 7 students. And I found that by doing 310 minus 303. If you want to find the amount of the change, that is going to be the difference, meaning subtract, between the new amount and the old amount. And you're always going to do biggest minus smallest. So you might want to write that in your notes, biggest minus smallest, no matter which one came first. So here, my difference is 7. So I'm going to put that into the proportion. Okay, so I'm going to have 7 over the original amount, the one that came first in time. Last year came first in time before this year. So I need to put the amount of last year's students, that's my original amount, on the bottom. And that is going to equal my percent, which I don't know, over 100. And now I'm going to cross multiply and I'm going to solve this. 7 times 100 is 700. And I'm going to divide by this number that's opposite my variable, 303. And that gives me a big long decimal number, which I could round to, let's say, about, so I'm going to use my about sign instead of my equal sign, 2.3%. Now we have to be careful when we do these percent problems and we're finding percent. Remember, it was asking us for the percent. What is the percent of change? So we knew that our answer was going to be a percent. And this is already written as how many out of 100. So I don't have to move my decimal point or anything when I'm thinking about this. That is the percent number, because it was what out of 100. So it'd be 2.3%. So there was a 2.3% increase in students from last year to this year. That's percent increase and decrease. And the important thing is just thinking about, okay, amount of change over original amount. If you remember that, you've got it. Discount. We're going to keep thinking about amount of change over original amount in all of these situations. We're going to be talking about a discount. And you may or may not have heard of a discount. I'm assuming most of you have. So just a couple notes about discount that sometimes people don't understand. Discounts are found before tax. So if I go to a store and it says it's 25% off sweaters or something, and I buy 2 sweaters, they're going to find the total cost, and then they're going to take the discount first and then charge tax on that. You only pay tax on what you're actually spending. You don't pay tax on the original price. So we do the discount first, then we find tax. If I want to find the discounted price, then I subtract the discount from the original price, and that's going to give me the discounted price. So I have to be careful on these problems to look at what are they asking me for. Are they wanting to know the amount of the discount? Do you want to know how much you're going to save? Do they want to know the discounted price, how much you're going to spend? Do they want to know the price after tax? In which case, you have to take off the discount, find the tax, add the tax on. So be careful when you look at these and just make sure you're reading the problem carefully. This problem right here is asking for the percent of the discount. They're telling me the original price and they're telling me the discounted price, and they want me to find the percent of discount. So it says, during a clearance sale, a keyboard that normally sells for $49.99 is discounted to $34.99, and they want to know what is the percent of the discount. So here, I'm going to do the amount of the change. How much did they take off? Put that over the original amount, the one that came first, and then find my percent. So if I want to know the amount of the change, I'm going to take, again, the difference between the two. $49.99 minus $34.99, and so that will be $15. So I'm getting a $15 discount. So when I set up my proportion, I'm going to do my amount of my change, $15, over my original price. The original price was $49.99 before the discount, and that's going to equal my percent over 100. So again, I'm going to cross multiply and solve. 15 times 100 is 1,500, and I need to divide that by 49.99. So if I look at that, it looks like, and this is a percent, so I don't have to worry about numbers after the decimal point. That is awfully darn close to 30%. So I'm going to say that that is about 30%. They probably did a 30% discount, and then when they rounded, it got off a little bit because they rounded to the nearest cent. But that is a 30% discount, basically. The answer to the free response question for today is stir crazy. Here is another type of problem that I might solve that is also a percent of change problem, and that is markup. Now, markup is the difference between the selling price and a store's cost for an item. So, stores, the whole purpose is to make money. They're not there just to give you stuff for free. And so they buy things for cheaper and then sell them for more. That's how they make money. I'm still going to use this proportion right here where I have the amount of change over the original amount equals percent over 100. So a store buys a set of headphones for $17.95 and then sells them for $35.79, and they want to know what is the percent of the markup. Okay, well, in this case, we know the original amount, we know how much they sell it for, and so we're going to put things in. We need to know the amount of the change. So we have $17.95 and we have $35.79. And remember, we're just finding the difference here. So I'm always going to do the bigger number minus the smaller number, no matter what. That will tell me how much the change was. $35.79 minus 17.95 gives me $17.84. Is how much they added on to the price. So this is my amount of change. It's not like the change you're going to get, but the amount of the change in the price. Okay, so when I set up my proportion, I am going to do $17.84. How much they changed the price by. And I'm going to put that over the original amount. First, the store bought the item, then they sold it. So the original amount is how much the store paid for it. And that equals, again, my percent over 100. I'm trying to find the percent of the markup. So now, once again, I'm going to cross multiply. I will get 1,784. I'm going to divide that by 17.95. And you can see that that is just about equal to 99% if I round that to the nearest percent. So they have marked it up almost 100%, meaning they've almost doubled the price, which you can see. They paid $17.95, they added $17.84 onto the price, and so my markup is almost 100%, not quite. 100% markup would mean that they just exactly doubled the price. Here are your free response and multiple choice questions, so go ahead and answer those, and then have a wonderful and spectacular rest of the day.